Today we have a lot to cover. Based on the syllabus, we are going to cover two sections, section 8.3 and section 8.4. Firstly, let's go to our Blackboard course shell and get a picture from my table note. One of the pictures is about the two sections. So let me download this. Open. Save image. Okay. So today we cover simple interest and compound interest. We focus on understand the idea behind each type of interest and the difference between simple interest and compound interest. All right. So let's look at my table note here. I have a table here, and I have the table separated into two parts. This is the line in the middle separates the two parts. The part to the left describes simple interest, how simple interest works. And the part to the right of the line describes how compound interest work. All right. So firstly, let's look at simple interest. Understand some simple concept, some basics. Principal, interest, and interest rate. Okay. So what is principal? Principal is the original amount of money you deposit in an account in the case you invest, or the original amount of money you borrow from the lender in the case of borrowing money. Okay, so if you invest and you deposit a certain amount of money in the account, and that amount of money is called the principal. And of course, when you invest, you want to have interest, have more money, right? Because when you deposit the money in the account for a certain period of time, you sacrifice the usage of the money during the time. So as exchange, you will have more than you deposit in the future from the account. So the extra money, the money more than what you deposit is the interest. So the original amount of money you deposit in the account for investment is a principal. In the case of borrowing money, for example, you borrow money to buy a car, right? And the original amount of money you borrow, that's the principal. But since nothing is free, right? You borrow money, eventually you have to return the money. Not just to return the money, you have to return more than what you have borrowed. The extra money is the interest. That's the reason the lender is willing to give the money, right, to buy the car. So in the case of borrowing or taking out a loan, the original amount of money you borrow from the lender is the principal. All right. And the interest I also already explained. When you deposit the money in an account for investment in the future, the account has more than you deposit originally, then the extra money is the interest. In the case of borrowing, you need to repay the lender more than you borrowed. The difference is the interest. All right. So my table note only consider investment just for convenience. I have what I have here is the case of investing. How do you investing? You investing in a chicken. Okay. The case of simple interest, you invest money and you bought a chicken, and the chicken you expect the chicken to lay eggs for you, right? Let's say the chicken, generally speaking, would lay 4 eggs every year. Okay, so by the end of year 1, you still have the chicken, that's your principal, and you have more than just your chicken, you have 4 more eggs. The 4 more eggs is your interest over the first year. In the case of simple interest, every year Every year your chicken lay 4 eggs for you. Every year your chicken lay 4 eggs for you. The principal, the chicken, the original chicken stay the same the entire time. But every year you have 4 eggs as interest. By the end of the first year, you have your principal, the chicken, and you have 4 eggs as interest. And over the second year, you have your chicken. Also, you have 4 more new eggs. So the end of year 2, you have 8 eggs, right? Let's assume the eggs do not go bad. You understand this is just a way to explain how do simple interest and the compound interest work. Those chicken just a hypothetical chicken, all right? Not really the chicken that you raise in your backyard. It's different. I hear someone leave message. Hi, Emma. Okay. Again, please remind me when we get closer to the end of the class. All right. I prefer you do that when we get closer to the class. Yeah. So then by the end of year 3, because every year you have 4 eggs, right? After 3 years, how many eggs do you have? You have 3 times 4, which is 12 eggs, right? And then keep going. Can I ask you a question? In this case, when the account pays a simple interest, when your chicken lay 4 eggs every year, what do you have by the end of year 10? Can you tell me what do you have by the end of year 10? Suppose your chicken does not die. Suppose the chicken lay 4 eggs every year for you. By the end of year 10, what do you have? Yeah, what do you own? 40 what? 40, what is the 40 mean? 40 eggs. Oh, okay, thank you. Do you still have a chicken? You still have your chicken, right? Your principal is still there. Okay, very good. Awesome. So this is simple picture demonstrate how does a simple interest work. In the case of a simple interest, your principal stays the same. Your principal does not change. You have 1 chicken in the very beginning. You have 1 chicken the entire time. You never have more than just 1 chicken, just 1 chicken. All right. And your interest, you have the same amount interest every year. You have the same amount of interest every year. So simple interest is very easy to compute. This is the formula for simple interest. Let me explain the meanings for those variables. P here, capital letter P, represents principal. We understand what is principal, right? The original amount of money you deposit in an account for more interest, right? For the purpose of interest. P represents principal. In our picture, the principal is the chicken. The little lowercase r represent annual interest rate. Has to be annual. R here is a default as annual interest rate, not semi-annual, quarterly interest or monthly interest or daily interest rate. R here is a default as an annual interest rate. Okay. T here is time in year, very important. T here, the value of T has to be the number of years. So if you invest your money in the account for 20 years, the value of T is 20 when you apply the formula. When you deposit your money and keep your money in the account for 18 months, guys, I need your attention. Suppose you deposit your money in an account for 18 months. What's the value for T when you apply this formula to find the interest? I here represents interest. What is T? Okay, let me repeat my question. We are talking about the meaning of this formula, right? This is the formula to compute the interest in dollar. P is the principal. R here is the annual interest rate. Suppose you put your money, your principal, in an account for 18 months. What's the value of T? T here represents time in year. Are you gonna let T be 18 or exactly? Very good. Thank you, Jennifer. Perfect. Thank you, Ashlyn. is not 18. Okay, if you let 18 be let t be 18, that means you keep your money in the account for 18 years. Okay, again, t here is time in year. Very, very important. I hope you have my attention. I have your attention here. I hope I have your attention here. T here is time in year. If the time period you invest in the account is 18 months, you have to convert the time in months to the same amount of time in year. We know there are 1.5 years in 18 months, right? Yeah. So how do you convert? You just divide the number of months by 12. Okay? Yeah, if the number of months is weird, like 20, not convenient, just divide 20 by 12. To convert from months to year, divide the number of months. Divide the number of months by 12. You will have the number of years. And the three numbers multiplied together gives you the interest rate. Okay, the interest in dollar. And A here is accumulated balance of your account. A is the initial of accumulated. A is the accumulated balance in your account. In the case of investment, you will have more than you deposited at the very beginning, right? The extra is the interest. So principal plus the interest is your accumulated balance. Let's say by the end of year 3, you still have your principal, the chicken, and you have 12x as the interest. Those are the interest from the 3 years, and the whole thing is your accumulated balance in your account, in your farm. All right, you do have more than what you invested in. You only invest in the chicken, but you have more than just chicken. You have 12x. So that's how does simple interest, how does an account paying simple interest work? Is that clear? It's pretty simple, right? Really not much to talk about. Okay, awesome. And now let's look at the part in the table to the right of the line. The part to the right describes the compound interest. All right, we're still talking about investing. The very beginning, okay, the very beginning, you purchased a chicken, all right, and by the end of the first year, over the first year, your chicken gave you 4x. So by the end of the year 1, you have the chicken, you still have the chicken, and you also have the 4x. Instead of the x, instead of staying as x, in the compound interest case, the 4x going to turn into chickens the beginning of year 2. In a farm, if they do not hatch eggs, they will not have more chicken, right? So let's say those 4x are taken good care of, and the 4x turn into chickens the beginning of year 2. Then the beginning of year 2, you do not just have one chicken, you have 1, 2, 3, 4, 5. You have 5 chickens. And then each chicken, remember, each chicken give you 4 eggs every year. So over year 2, during the year 2, since you have 5 chickens, each chicken give you 4 eggs. The 5 chickens give you 20 eggs, right? Yeah, those interest is just the interest over year 2. And also are your eggs, accumulated eggs, because the eggs, the 4 eggs from year 1 turn into chicken, right? Yeah, you don't have eggs anymore, but you have more chicken. So what happened is, since your eggs become chicken, the beginning of year 2, your principal grows. Your principal grows. From 1 chicken, now 5 chicken, right? More chicken, of course, give you more eggs. During year 2, you will have 20 eggs, okay? And those 20 eggs do not stay as eggs. They are going to turn into chickens as well. So the beginning of year 3, you have 5 chickens, and then over the year 2, you have 20 eggs. Those 20 eggs gonna become chickens, join the team of principal. And how many chickens do you have at the beginning of year 3? You have 5 here and 20, 25 chickens, right? 25 chickens. And again, your principal grows. Yeah, beginning of year 1, you only have 1 chicken. That's your principal. Beginning of year 2, you have 5 chickens. Your principal does not stay the same. Instead, it grows, it increases, right? And the beginning of year 3, you have 25 chickens. Over the year 3, those 25 chickens gonna give you a lot of eggs, right? Because 1 chicken give you 4 eggs, and those 25 chickens gonna give you 100 chickens. That's how people get rich. Exponential effect, right? That's how people get rich, have a huge farm. And you can continue think about, I don't have it in my table, but you can consider those 100 eggs gonna become chicken. So the beginning of year 4, you're gonna have 125 chicken. And those 125 chicken give you times 4 eggs, right? Yeah, you're gonna have 500 eggs, and so on and so on and so on. So yeah, very powerful. And this is how compound interest work. Let me summarize. In the case of a compound interest, your principal does not stay the same. Your principal changes. Your principal grows. Because every time you have an interest generated, the interest will join the principal and become part of the principal, make the amount of principal bigger. And a bigger principal will give you more interest. Yeah, every time you have a new interest, the interest will become part of the principal. And when the principal getting bigger and bigger, and every time period, in this case year, every year you have more chicken, right? And when those chicken, more eggs, sorry, when those eggs are generated, they gonna become part of the chicken and make the principal bigger and bigger, and the eggs more and more. So that's how compound interest work. As you can see, compound interest is very, very powerful. It kicked me. Oh, sorry about that. Guys, is that clear, everybody? Do you see the difference between simple interest and compound interest? Yeah, yeah, that's the difference. Okay, in simple interest, your principal stay the same all the time. Okay, your principal stay the same all the time. Your interest stay as interest. But in the case of compound interest, every time you have interest, the interest will become part of the principal, make the principal bigger. when the principal become bigger, you have more interest. Yeah, every time you have interest, the interest will become part of the principal. And talking about the formulas of compound interest, yeah, that's the main thing. Okay, that's the main thing. We need to understand how do simple interest and compound interest work. Also, we need to see the difference between those two types of interest. But when we actually solve problems, we need to choose the correct formulas, right? Yeah, to calculate the interest and accumulated balance. So let me explain this formula. P here, okay, A here is the accumulated balance, all right? And which is equal to P. P here is the principal, but is the original principal. As you can see, when we talk about compound interest, principal changes, right? Principal getting bigger and bigger. So P here is the original principal, like that 1 chicken, that's the original principal. And the parentheses, inside the parentheses, we have a 1 plus R over N. 1 is just number 1. R again, annual interest rate. R here always represent annual interest rate. N here is very important, okay? N here is the number of times your interest is compounded every year. We're going to talk about that in detail in a moment. And T here is time in year. All right. So my picture is when n equals 1, means the chicken lay eggs once a year for you. So n equals 1. What if those chickens, what if your chicken lay eggs twice a year? Then you would have interest generated twice a year, right? 2. So in that case, n equals 2. What if your chicken lay eggs every a quarter, 4 times a year, every 3 months? Then n equals 4. That means you have interests generated 4 times per year. What if your interest is generated once a month? Your chicken lay eggs every month. Then n equals 12. Means you have interest, new interest generated twice a year, right? And what if your chicken lay eggs every day? Okay, think about that. It's very powerful, right? And n would be 365. Sometimes we use 360. Depends on the instruction of the question. Means you have a new interests 365 times per year. So you plug in those values and you would see, you would have the accumulated balance for compound interest. And use accumulated balance to minus the original principal. The difference would be your compound interest amount in dollar. All right, yeah, do not worry about if you don't, because I'm just talking about we don't even have an example yet. Yeah, later we will look at the examples and I will show you how to apply those formula. And I also have another table note. Let me, this one, can I go back now? Yeah, let's go back I have another table note in this section, this part. Yeah, I'm gonna just show you here. It's about the formula, okay? So we want to understand, we want to know a concept or a term is called a compounding factor. Compounding factor. What is a compounding factor? What's the structure of compounding factor? Compounding factor is number 1 plus a rate. If your interest is compounded once a year, means your chicken lay eggs once a year, all right? Then the compounding factor is just 1 plus annual interest rate. Annual interest rate, all right? And what if your chicken lay eggs twice a year, every half a year? Then the compounding factor is 1 plus semi-annual interest rate. R here is still annual interest rate. Divide the annual interest rate by 2. We have a semi-annual interest rate. You can understand interest rate as a productivity. If you make the chicken lay eggs twice a year, then each time I believe that the chicken will, lower the productivity because you are too harsh. Yeah, suppose lay eggs once a year. Now you make me do twice a year. Or each time I'm gonna give you less, right? Yeah, how much less? Half less, R over 2. So the compounding factor is always 1 plus a rate. In the case of semi-annually, interest compounded semi-annually is 1 plus semi-annual interest rate. In the case the interest compounded 4 times a year quarterly, it is 1 plus quarter interest rate. And R again, also still annual interest rate divided by 4 is a quarter interest rate. And if it's monthly, the compounding factor is 1 plus monthly interest rate, which is annual interest rate divided by 12. If the interest is compounded by daily, then the compounding factor is 1 plus R over 365. R here is the annual interest rate. Divide the annual interest rate by 365. We have a daily interest rate. So do you see what happened, everybody? If it's n times a year, then the compounding factor would be 1 plus R over n. We have learned inductive and deductive reasonings, right? Do you see the pattern? Am I clear about what is the compounding factor? It's number 1 plus a rate, right? Yeah, what's the rate? Depends on how your interest is compounded. If it's compounded annually, annual interest rate. compounded quarterly, quarterly interest rate, compounded monthly, monthly interest rate, right? So remember, okay, the compounding factor is always 1 plus the rate, is always 1 plus the rate. And corresponding each compounding situation, we also can understand what is the compounding period. If your interest is compounded once a year, then 1 year is the compounding period. If your interest is compounded semi-annually, then the compounding period is 6 months, half a year. If your interest is compounded quarterly, your compounding period is 3 months. If it's monthly, compounding period is 1 month, right? Yeah, like your chicken lay eggs every month, once a month, end of each month. If the interest is compounded daily, the compounding period is 1 day. All right. So if your so how do we use compounding factor? How do we use compounding factor? It's very cool here. The reason I really need you to understand compounding factor is because of this fact. What fact? Let's say this is the accumulated balance. Yeah, the money in the account at a certain point. This P is your original principal, the how much money you put in the account originally. Every time, depends on your account. Every time the interest is compounded, you multiply your principal by compounding factor once. All right? Every time your interest is, you have a new interest generated. Every time your interest is compounded, like new interest is generated and right away become part of the principal. So you multiply the current principal, yeah, at that time by the compounding factor 1 time. Okay, if it generated again, compounded again, you multiply compounding factor again. Okay, if we let's say n equals 2, yeah, let's say n equals 2, then the compounding factor is 1 plus semi-annual interest rate, all right? So 1 plus r equals 2. So by the end of 6 months, you multiply this because your interest is compounded once. Multiply the compounding factor once. After another half a year, your interest is gonna compound 1 more time, right? Yes. Multiply another compounding factor. Every time your interest is compounded, multiply your compounding factor once. Depends on how many times. If you put your money in an account for 10 years, then you're gonna multiply the compounding factor for how many times? Half a year. Yeah, every 6 months, 1 time. For 10 years, that's gonna be 20, right? You just need to multiply your original principal by the compounding factor 20 times. Does that make sense, everybody? Yeah, how does the compounding factor work? Every time your interest is compounded, you just need to multiply the money you have right now in the account by the compounding factor once. Okay, that's how it works. The interesting thing is the same thing, 1 plus the rate, can also be the discounting discounting factor. We don't talk about discounting, we only talk about compounding. Compounding is you always multiply. Discounting, you divide. So when your money devaluating, you do discounting, you divide it by the factor. But now we're talking about compounding, you just multiply the factor, all right? I think the best way is to really look at the problem and solve the problem. Let me get the notes. The notes is also in Blackboard. I have 2 sets of notes posted. One is my table note. I really spent a lot of time and heart, put a lot of effort in the table notes. And then the other set is from our publisher, 8.3 and 8.4. 8.3, simple interest, 8.4 compound interest. We cover both in the same class, okay? So this section is simple interest. Let's find some problem to practice. Let's do this problem. You deposited $2,000 in a savings account at a hometown bank, which has a rate of 1.2%. Find the interest at the end of the first year. Okay. You are looking for, this is a simple interest, okay? This is simple interest. It only says 1 year, which has a rate of find the interest at the end of the first year. So based on the information that is given, we know this is a simple interest and for the time period of 1 year. And the formula for simple interest, I equals P times R times T. Let me explain the meaning again. I is the interest in dollar. R is the interest rate in percentage. Yeah, please make a difference between those two. Again, I is the interest in dollar. Interest amount in dollar. R is the interest rate. It's going to be a percentage. In this case, 1.2%. It has no unit, all right? P is the principal. T here is time in year. Very important. Yeah, in this example, 1 year. It says at the end of the first year, right? So T equals 1. And our P is you deposit 2,000. Our R is 1.2%. T is 1 year. And multiply the three things together, we will have the interest by the end of the first year, right? Yeah, let's see the calculation. 2,000 times 1.2% times 1. And 2,000 times 1.2% 0.012. We're gonna have 20. We're gonna have 1, 2, 3, 12 times 2, 24. $24. Really that little? Yeah, because the interest rate is very low, right? Let me double check. 1.2%, so 1.2 divided by 100 times 2,000. 3, $24, right? $24. So the interest from the account after 1 year is $24. It's very little. It's just 1 year. Also, the interest rate is very low, 1.2%. Is that clear, everybody? Pretty straightforward, right? This one. How do we understand? Yeah, how do we understand the interest rate? Annual interest rate. How do we understand this annual interest rate? When the annual interest rate is 1.2%, 1.2 every 100% means every 100, right? That means every $100 you deposit by the end of the year, 1 year annual interest rate, you will have $1.20. Okay, if you invest in 100, from every $100 you invest in, you have $1.2. And if you every $1,000 you deposit, you would have $12, right? Just amplify by 10. And now you have 2,000, of course, $24. Doesn't that make perfect sense? Yeah. So seriously, you are welcome to use a formula to handle section 3.3 when you need to calculate the simple interest. But I really recommend try your common sense. Try to use the concept of annual interest rate Just use the sense, just use the common sense. If the annual interest rate is 1.2%, that means for every $100 you deposit, you pay $1.20. You have $1.20 for 1 year, right? And that's what happens. And by the way, I need to explain in my table note. So in reality, when do we use simple interest? When do we use compound interest? In reality, when we take out a loan, the loan is using simple interest. Home loan, student loan, auto loan, yeah, or small business loan. Those loans give you simple interest. Okay, is the savings plan, investment plan, savings plan. We mentioned IRA, HSA the other day. Yeah, those savings plan pays you compound interest. All right. So in reality, we do not really pay compound interest for loan unless it's illegal. You know, some private lender. Okay. In general, loans pay simple interest. Savings plan pays compound interest. So far, so good. Okay. So let's keep practicing. We 40 minutes. We want to practice a few more, and then we're gonna go to compound interest problems. Let's look at this one. A student took out a loan, right? Simple interest loan for $1,800 for 2 years at a rate of 8% to purchase a bicycle and a laptop. What's the interest on the loan? Okay. Yeah, we can use the formula. Let's use the formula. Formula I equals P times R times T. Plugging in, right? Principal is the original amount of money you borrow from the lender, 1,800. Annual interest rate, always annual, 8%. Times T, time in year, 2 years, right? So 2. And you just need to use a calculator to figure out the result. Yeah, let's use a calculator. 1,800 times 8% is 0.08, and then times 2, $288. $288. So after 2 years, you are going to repay the lender the $1,800. On top of that, $288. So in 2 years, you need to pay $2,088. Yeah, the lender not just give you money for nothing. They give you money because they want the interest, right? Okay. More questions. Okay. So what if we use a sense? We just make sense the number, the value of the annual interest rate 8%. 8%. Yeah, sometimes when the number is convenient, it's pretty. We can do it very quickly. Think about 8% annual interest rate means every $100 you borrow from the lender, you're gonna repay $8. $8 more, right? Yeah, you have to repay the principal for sure. The interest is $8. So you have $1,800. You borrow $1,800. So every time you borrow $100, you repay $8 as interest, right? And now you borrowed $1,800. Now of course you use 18 times 8, right? You use 18 times 8. And that's how much interest you owe for 1 year. But now you keep the money for 2 years. You just need to double it, right? So you can just, without using formula, just use the sense, the meaning of the annual interest rate. You can, yeah, find the value as well. Yeah, I would like you to try both, especially Yeah, what does the annual interest really mean? It means every $100 you borrow, that's the cost. Yeah, 8%. Annual interest rate it tells you how much the cost is every time you borrow $100. Yeah, the cost of borrowing $100 is $8. Okay, if you borrow 1,800, then you times 18 by multiply 8 by 18, right? 144. That's for 1 year. Annual interest rate, right? Yeah, the cost for 1 year. Cost for 1 year. All right, more practice. Suppose you spend $4.95 each day. Oh, I don't like this problem. Let's keep going. In order to start a small business, a student takes out a simple interest loan for $4,000 for 9 months at a rate of 8.25%. Okay, this again is the annual interest rate. Annual interest rate. They will not tell you it's annual interest rate. It's defaulted as annual. Okay, how much the interest? Okay, so let's use a formula. You can choose to use a formula. What is P? Principal. The student borrowed a loan of 4,000. Annual interest rate 8.25%. Right? T. Anybody can tell me what's the T? What's the value of T here? Well, the student did not keep the money for 1 year. If it's 1 year, we multiply by 1. T equals 1, right? It's not 9 years, it's 9 months, less than a year. Then what's the value of T? You prorate. Yeah, exactly. 3/4. Awesome. 3/4, right? What is 108 mean? 3/4. Very good. So 0.75 was 3/4, right? Yeah. And we can calculate to find the interest. So 4,000 times 8.25 divided by 100 is 0.0825. And then times 0.75. 247.5. So after 9 months, the student need to repay the lender $4,000 and also the interest, right? So the future value of the loan means the accumulated balance of your account, of the account that you handle the loan. Okay, so it is 4,000 plus 247.5 is $4,247.50. That is the future value of the loan. Yeah, in 9 months, you do not just repay 4,000, and the lender again do not help you with nothing, right? You have to pay more than what you borrowed. You pay $247.50 more. So future value of the loan means the addition of the principal and the interest. All right. So is that clear, guys? Is that clear, guys? Simple interest rate pretty simple, right? Yeah, simple interest is pretty simple. And now let's look at compound interest. Let's find the problems about compound interest. I downloaded the guided note. When we actually solve the problem for compound interest, we mainly depend on the formula, all right? We mainly depend on formula. From next class on Wednesday, we're gonna use TI-84 calculator. Today we don't. On Wednesday we do. So if you still don't have a TI-84 calculator yet, you really should try to get one. Let's find a problem. Let me see this problem. Okay, this is a good one. Okay, let's do this one. You deposit $2,000 in a savings account. In reality, savings plan pays compound interest at a hometown bank, which has a rate of 1.6%. That is the annual interest rate. Again, annual. Part A, find the amount A of money in account after 3 years, subject to interest compounded once a year. So this is a very important information. Compounded once a year, right? Yeah, means your interest is compounded annually. You wanna on your scratch paper write down a keyword annually. Your interest is compounded annually. So your compounding factor is 1 plus annual interest rate. Remember, compounding factor is always 1 plus the rate. Since your interest is compounded annually, so it's 1 plus the annual interest rate. Okay, so let's see how much money do you have in the account after 3 years. You start from P. You start from P. What is P? P. Original principal, $2,000. Okay. You start from $2,000, right? That's the money you originally put in the account. Okay. Once a year, your interest is compounded. Every time your interest is compounded, you multiply the compounding factor 1 time. Again, your compounding factor is 1 plus the rate. Since your interest is compounded annually, is 1 plus annual interest rate. Right? Yeah, once a year. For how many times? It says after 3 years. We want to know the balance after 3 years. So how many times the interest is compounded over 3 years? Please type your answer. How many times the interest is compounded over the 3 years? If the interest is compounded once a year. Once a year. Yeah, exactly. Correct. Actually, it is 3. 3 times a year. Oh, sorry, I misspoken. Once a year for 3 years. So 3 times. So it means you're going to multiply this compounding factor 3 times, right? But instead of you do that 3 times, you just do a cube. All right? We understand exponential expression, right? Yeah. 1 plus the compounding factor to the power of 3 basically means the compounding factor multiplied by itself 3 times. And that's your formula. That's your formula. Is that clear, guys? You do not even have to memorize those formulas. The system, Pearson, give you the formula, but seriously, you don't even have to memorize by row. Very clear. Okay, awesome. Happy to know that. All right, now I'm gonna get it a TID for a calculator. Yes, some of you might already have it. Let me show you how cool it is, right? TID for calculator, we can just enter the whole expression. Let me clear this one. I need to remember the numbers. Let me just look at it one more time. Original principal 2,000, 3 years, annual interest rate 1.6%. Okay. So this is how do I do? This is simple calculator. TID for calculator. I'm gonna do original principal 2,000, right? And multiply by my compounding factor 1 plus annual interest rate 1.6%. So if you really is better, you just convert it on your scratch paper. If you really want to do in a calculator, you can do 1.6 divided by 100. But you just need to use a set of parentheses to frame it. Okay, so in this set of parentheses, you have annual interest rate. It's just 1.6%. And then close this parentheses, this bigger one, that set of parentheses frame the compounding factor. And then raise, oh, that's a wrong key. Raise it to power of 3, right? This upside down V, yeah. I think there's something referred to that. I figured out. So raise that to the power of 3. You see, I have the whole expression entered in the calculator. It's cool if you know how to do that. If not, you can totally just do it by step, right? Yeah. How do you do it by step? For example, if you do it by step, I start with the annual interest rate. Annual interest rate is 1.6% or 0.016, right? Yeah, this is the annual interest rate. Plus 1 is my compounding factor, right? I raise the compounding factor 3 times to the power of 3 because the interest compounded 3 times over 3 years, right? And then I multiply that by 2000. Yeah, multiply 2000 the last step. Do I have the same thing? 2097, 2097, the same thing, right? Okay, so that's how we find the accumulated balance. Let's see how we run the result. It doesn't say, but let's run it to the nearest cent. 2097.54 2097.54. All right, that's your accumulated balance. So originally, the very beginning, you only put in 2000. But after 3 years, you have more than that. Yeah, the money exceeding 2000, that of course your interest, right? So your interest, yeah, just use common sense. Formulas are good. Only when you really understand the formula, you can quickly apply it. But if you just know how to apply the formula by using common sense, that'll be very cool as well. Okay, the interest of course is the extra money, right? That's how much money you have after 3 years, and 2000 is how much money you put in the very beginning. Then the difference 97.54, of course that's the compound interest amount in dollar, right? Is that clear, everybody? This problem, interest is compounded once a year annually. Yeah. What if it's not annually? Yeah, what if it's not annually? Let's find a problem. What if it is, this one is monthly? Okay, let's do this one. You deposited $7,500 in a savings account that has a rate of 1.2%. Again, this is the annual interest rate, okay? Annual interest rate. The interest is compounded monthly. This is all very important information. Compounded monthly. So let's see what is the compounding factor. Compounding factor is 1 plus the rate. Since your interest is compounded monthly, the rate here is going to be monthly interest rate, which is your annual interest rate divided by 12. Okay, 1 plus 1.2% divided by 12. Okay, or 1 plus 0.012 over 12. That's your compounding factor. All right, guys, do you see that? The compounding factor is not always 1 plus r. When the interest is compounded once a year, yes, it is 1 plus r. But when the interest is compounded more times a year, for example, 12 times a year, by month, then the compounding factor is 1 plus monthly interest rate. I mentioned this earlier, right? Monthly interest rate. Okay, let's see, how do we use the understanding about compounding factor to find a balance after 5 years? Is right here, 5 years. Originally, how much money you put in? 7,500, right? Yeah, 7,500. Originally, you put in $7,500. And by months, after 1 month, your interest compounded the very first time. So you multiply by the compounding factor once, 0.012 over 12. After another month, you're going to do that again. After another month, do it again. Another month, do it again. So Tell me, how many months in 5 years? How many months in 5 years? Awesome, exactly 60 times. 60 months in 5 years. So here, instead of multiplying the compounding factor 60 times, we are just going to raise the compounding factor to the power of 60. Means the same thing, right? Exponential expression is to represent repeated multiplication. So instead of multiplying the compounding factor for 60 times, we just raise the compounding factor to the power of 60. Does that make sense, everybody? And on a calculator, yeah, I need to remember 1.2%, 7,500. In a calculator, 7,500 multiplied by compounding factor 1 plus the rate here is 0.012 divided by 12. Close that, that's the monthly interest rate. Close 1 plus r, that's the compounding factor, and then raise to the power 60, right? Or what you can do is start from a compounding factor. Start from a compounding factor. Your annual interest rate is 0.012. Since the interest compounded monthly, divide by 12, monthly interest rate. Yeah, monthly interest rate plus 1 is the compounding factor. Raise the compounding factor to the power 60, right? And then multiply your principal, 7,500. And same thing, yeah, same result. 797963. We can round it to the nearest cent, so we round it up to 54 cents. Yeah, approximately equal to, because we round it. $7,963.54. That's the balance, right? Now, how much interest you end up getting is easy, right? Just again, use common sense. After 5 years, in your account, after 5 years, you have $7,963.54. But at the very beginning, you only put in 7,500. The difference, of course, is your interest, right? 463.54. $463.54. Question? Is that clear, everybody? Monthly interest rate. Monthly interest rate. Okay, very good. Cool. And you know, actually, I changed my mind. I'm going to introduce how to use TI-84 calculator, the finance application to solve compounding problem. We're gonna use the same problem here, right? Monthly, the interest compounded monthly. This example. Very important thing. In TI-84 calculator, you should have a finance application. Some of your calculator has more than just a finance application. So do you see the key APPS? You click APPS and you have a lot applications, right? We only use the first one, finance application. So I confirm finance. And now see the drop-down menu for calc. In the menu of calc, the first function is TVM solver. What is TVM means? TVM stands for time value of money. We do not consider inflation. We consider interest. Because of interest, $1 today is different value different, worth different from $1 in a year. You know what I'm saying? If we save the $1 today, in a year it has more. All right, it has more. So money has a time value. If we take inflation into consideration, just make the trend even more stronger. The money today, when the inflation go up, in the future, the money just worth less, right? When the tariff is in place in April, so inflation goes up, and your money worth less, can purchase less goods. So money has time value. So this is TVM solver. So in that solver, confirm that, you'll see a menu like this, and you're gonna correctly enter the values for each entry, and the calculator, the app will help you to calculate what you want. All right. Yeah, we can get a start to. Of course, you are welcome to use the formulas and the compounding factor to compute the result, right? But you can also use the app here. So let me explain what is N represent. Capital N here means, capital N here represents the total number of times your interest is compounded. In our example, the interest is compounded monthly, so 12 times a year for 5 years. 12 times a year for 5 years. Capital N is 60. Yeah, again, what does 60 mean? Is the number of times your chicken lay eggs for you. How many times you have interest compounded. Once a month over 5 years, 60 times. And I% is the annual interest rate. And you do not put a percent. All you need to do is to put the number in front of percent sign. In our case, is 1.2%, right? Instead of enter 0.012, you just need to enter 1.2. PV, yeah, you should take notes. PV stands for present value. Present value. In your account, you have $7,500 deposit at the very beginning, right? So 7,500. So I put a negative sign. You don't have to, by the way. I put a negative sign means the very beginning you put $7,500 in the account, so you have $7,500 leaving your pocket. So that's why I put a negative here. You really do not have to worry about the sign. It will not affect you getting the correct answer. Payment, we do not have any payment. Okay, we're gonna use this next time when we learn annuity. But when it comes to compound interest, since over the 5 years, you do not have any payment. You do not withdraw, you do not deposit extra, so payment is 0. We are looking for a future value. FV is a future value. Okay, FV is the future value of your account. Okay, so we are going to solve for this. Just to remind yourself, you can put a 99999 to remind yourself this variable is what we're trying to solve later. And too many nines, so that's what happened. How about just a few less nines? How about this? P per Y, C per Y. P per Y means the number of compounding period per year. Once a month, so it's 12. C per Y, number of compounding, number of times, compounding period. So this is a number of payment every year. So just know those two entries always have the same value. If the interest is compounded once a year, put a 1 here. If it's semi-annually, 2 here. Quarterly, 4 here. Monthly, 12 here. Daily, 365 here. So our example, interest compounded by monthly, so it's 12. So as you can see, if I change this to 2, right? If I change this to 12, automatically the C per Y change the same. So those two values are always the same. And the last row, PMT, end and begin. The entire course, our entire course, just remember, we only use END. We never use begin. Okay, so next time when we learn annuity, we would understand this entry better. But just remember the entire course, we never use begin, we only use end. And now we have all the entries in place. We can go back, future value, because the future value is what we want to look for, right? We want to know how much money in an account after 5 years, after 60 months. So leave your indicator blinking here, and then you do alpha, the green key, alpha, enter. You see the same value, right? And the value is a positive. Yeah, positive $7,963.54, because in 5 years, those money, if you do not, if you end the account, all right, the money gonna go back to your pocket, so it's a positive. All right, guys. So I think I am pretty clear. Some of you acknowledge that. I am recording the class, so if you have any confusion, I would recommend rewatch the class recording. And that's everything for this section. I'll see you essential in 10, and the other section I'll see you on Wednesday. Thank you guys for coming. And we have Emma. Who else? Emma? Yeah, this is the time you need to let me know. This is the time you need to let me know you were late. Just Emma? Okay. Just Emma. I'm gonna fix your attendance right now. I think it's 9:04. Levy was here earlier. Okay, now I'll fix hers. Thank you for letting me know. Appreciate that. Levy. Okay. Save. All right. Thank you. Yeah. And Charlie, I emailed you to look at the email. I'll see you later.